Okay, welcome to another video. I hope you're all doing well. Today I'm going to be looking at section 5.5, homework problem number 4, which gives you a system of inequalities and it wants you to fill in on the graph where that solution to the system is. Okay, so I'm not sure if you can see this very well. I'll rewrite this system here. But it is x minus y is greater than or equal to 0, and then x plus y is greater than or equal to 2. Okay? So those are the two inequalities that I'm dealing with, and I'm wondering what part of this graph will they fill in. Okay? So this line here, this is x minus y equals 0, so that's going to be the boundary for this one. And then x plus y is equal to 2 is this other line, okay? When it equals 2, that's the boundary for this other inequality, okay? And now we just have to figure out what sides is this going to be at, okay? And really, to get this to work, there's several ways that you can go about it. It's hard to tell with these equations, inequalities, they're not equations, okay? It's hard to tell with these inequalities actually what side of the line they're on because they're not in a y equals form or a y is greater than form, okay? So if you want to just be able to look at the inequality and tell which side these are going to be on, you need to solve for y, okay? The other thing you could do here is you could plug in points to figure out which side it works on, okay? I'm going to solve for y. I think the book usually is plugging in points, so it's whatever works better for you. But essentially, like for this one, if I wanted to know which side of the inequality would be satisfied by this one, well, I just pick a point somewhere on one side or the other of the line, so maybe like this point here, and I would plug that in for x and y and see if that works. And if it works, then it's going to be on this side of the line, okay? And if it doesn't, it's on the other side, okay? But I'm going to show you how to do it just solving for y, okay? So let's solve for y in these inequalities. So this is A. We've got x minus y is greater than or equal to 0. So I'm going to subtract x over. I get negative y is greater than or equal to negative x, okay? And so with that, I can convert that over to just divide by a negative on both sides. Now, if I divide by a negative on both sides, what happens to the inequality? It flips, right? So I get y is less than or equal to x, okay, when I divide by that negative. Okay, so that's my first inequality there. My second inequality is x plus y is greater than or equal to 2. So to get y alone, I'm just going to subtract x from both sides. So my second inequality here would be y is, it's going to be greater than or equal to, subtract x from both sides, 2 minus x. Okay? So those are my two inequalities now written with y by itself. Okay? And now we can just tell by looking at the inequalities, y being less than or equal to x, okay, that was corresponding to this line here, the x minus y equals 0. We're wondering, well, where is y smaller than x? Okay, well, that will happen when y is small, right? Y should be smaller than x, and so I'm going to be below this line. My y values are going to be below. So this line we're going to be below the line. This other one, y is greater than 2 minus x, means that your y value is going to be large, right? It's going to be bigger than 2 minus x. And so here's the line, the boundary corresponding to that inequality. So y needs to be big, so I need to be above the line. Okay? So that would shade in this whole region here, this part of the graph up to that line. Okay? Now, for the system of inequalities to work, I need both to happen at the same time for it to be a solution. So my answer here is, well, where do both of these happen? The green is down here, the red is up here, right? So it's in this triangle right here. This, well, not really a triangle because it goes up forever. That's really lagging. Okay, so that would be our solution set here. Okay, so essentially, kind of maybe a tricky thing here is you might have to actually solve for y in these to be able to tell what sides they're on. Or you could just plug in points. Either one works. That's fine. Okay. So for B, it's a similar thing, just we have x minus y is less than or equal to 0. Okay, so what happened here was, so this is x minus y is less than or equal to 0, and then x plus y is less than or equal to 2, in case you can't see that. So those are the two inequalities I'm dealing with. So how did I change this? I just flipped both of those inequalities, okay? So I changed these ones from being greater thans to being less than or equal to's, right? And when I switch both of them, essentially what that's going to do is this line before on this one was above the line, but when I switch the inequality, it's going to make it below the line. Okay, so because we're just switching both inequalities here, both of them will switch. Okay, so this one will be below, and then this one was below, the green one, so now it's going to be above the line. So it would look like that. And so where do both of those happen? Well, it's going to be in this region right here. Okay? So that's our solution there. Okay? So kind of the strategy here is it's a lot better. You can tell easier what's going on with these inequalities if you have them solved for y. Now, some things like circles, you can't really solve for y very well, so it's probably better just to plug in points to figure out which one works, but this is fine. Ooh, sorry, for us, okay? Let's look at C and D. Oh, this is really lagging. Okay. So in case you can't see, I'll rewrite these inequalities. X minus y is greater than or equal to 0, and x plus y is less than or equal to 2. Okay. So I'm going to demonstrate doing this one by plugging in points, okay? So that we can kind of see another way of doing this so that we can kind of see which way you like better, okay? So this is our system of inequalities. What I'm going to do is I'm going to pick a point that's probably above and below, or above or below the line. So this is x minus y equals 0. So we'll just pick a point below the line, maybe here. This is at the point 1, 0. Okay? So when I plug that point into this inequality, what I want to know is it true? Okay? When I plug in x equals 1, y equals 0, does this work? Okay. Well, I do 1 minus 0 is 1. Is that greater than or equal to 0? Yes, it is. Okay. And so we know that this x minus y equals 0. This is our boundary line, right? We know that this one works, so we know that we're going to be below this line. Okay. It's going to be all the stuff down here. Okay. Now what about my other line? I could plug in that same point. This is now the boundary line of this inequality, so I'll plug in that same point, 1, 0, and see if it's true. Okay, so 1, 0, I do 1 plus 0 is 1. Is that less than or equal to 2? Well, 1 is less than or equal to 2, so this point does work in this inequality too. So I know for this line here, I'm going to have all the points below this line. Okay? And so then we just have to think about, where do both of them happen? Well, it's in this corner right here. We actually picked a point where they both worked originally, so it would be that quarter of it. Okay? And then you'll notice actually that on this one, both of our inequalities are flipped for D. They just switched the greater than symbol here to be a less than symbol, and the less than symbol here to be a greater than. And so essentially that will flip our answer, as instead of being below this line, it's going to be above. Okay? And instead of being below this line, the green, we're going to be above this line. And so then where is that going to happen? Where both of them are true is going to be in this corner right there. Okay? So hopefully that helps with this homework problem. Essentially, right, kind of the tricky thing is you can either plug in points to figure out where the inequalities work, or you can solve for y in them to kind of just look at, well, is it a greater than or a less than, to see whether you should be above or below. Okay? Have a good one. I'll see you soon.